their values. You have to calculate your input power and then subtract your losses from the input power divided by pi to find the efficiency. Okay, one thing that I should mention is that the efficiency depends on your input output voltages, depends on your frequency, depends on the output current, the load current. Okay, so one buck converter or one boost converter doesn't have the same efficiency for all the input voltages, output voltages. Usually, like for example, this is a curve for one device. It might be something like this, right? Output voltage, efficiency, right? So the efficiency of the same device might be something for high voltages, but might be much lower for low voltages, low output voltages. So you have to know that. You might have the same power losses, right? You might have similar level power losses, but your efficiency, it's gonna be different. So never just get fooled down like by somebody saying that, oh, this device has like a certain very high output efficiency. You have to ask like, oh, for what parameters? What is the power loss, right? Then you can just compare, like don't compare apples and oranges. Like if you want to compare two devices, their efficiency, like you have to know what are the parameters. The parameters has to be exactly the same. Okay, so this is like one other thing I wanted to mention about efficiency. So this is like how you can calculate efficiency. You basically have to calculate all the losses that we did, like all the conduction losses, 4 conduction losses, 2 switching losses. One was reverse recovery, one was like due to T on T off. This one was transistor conduction losses, diode conduction losses, and diode had 2 parts, like one for voltage of forward bias plus resistance of the forward bias, inductor conduction losses, and capacitor conduction losses. So calculate all these 6, subtract it from your input power, divided by input power, you would have your efficiency. That's the definition of efficiency. So there's some examples in your course notes. Please go through them. I'm gonna also like give you another example here. This one, it's not a buck or boost converter, it's just like another power electronic device. So this is V in. Okay, I want you to calculate the power losses for this circuit, like all the power that's lost in this circuit. So these are the parameters that I'm giving you. The duty cycle is 0.6. The switching frequency is 100 kilohertz. V in is 200 volts. So basically we are like turning this on and off with this duty cycle. I is equal to 10 amp. Okay, VDD is equal to V in is equal to 200 volt. ID 0 is equal to 10 amp. RDS on is equal to 50 milliohm. T of rise is equal to T of rise for current. T of rise for voltage is equal to 10 nanosecond. And T of fall is equal to T of fall for current. T of fall for voltage is equal to 8 nanoseconds. And QRR, you can assume it's 0. So like, let's just like not worry about the other switching losses. Okay, so I want you to calculate this, and once you have, this is the final answer that I have, 6.6 watts. If you get this, it means that you're doing it right. If not, I'm gonna solve it in another video soon. Okay, thank you so much. Goodbye for now.